Bismillahirrahmanirrahim. BS Physics, Semester 1, Mechanics, Course Code Physics 1103, Chapter 7 का third lecture, Oral 23. Chapter 7 है Energy and Energy Transformation. The name of this lecture is Work Energy Theorem and Conservation of Energy. Dear students, I am talking to you, Rashmat Ali, Assistant Professor of Physics, Khaja Preet Government Postgraduate College, Rimia Khan. The material of this lecture has been taken from the outlines of BS syllabus as recommended by the University, Physics for the Scientists and Engineers by Survey Javed, Fundamentals of Physics by Halliday and Resnick, also the Gerald Walker. The main title image of the chapter, that's the windmill. The main topics, contents of this lecture is the conservation of energy, situations involving kinetic friction, work energy theorem for kinetic friction in presence of other forces. So first of all, we study the conservation of energy. This is basically fundamental law of conservation of energy of physics statement. Energy can neither be created nor be destroyed, but can be converted from one form to another form. That is, energy is always conserved. It means that energy for a system is always same, but it can be converted from one form to another form. Secondly, if the total amount of energy in a system changes, it can only be due to the fact that the energy has crossed the boundary of system by a transfer mechanism, such as one of the methods of listed above. Means if we are considering a system, if energy of the system is going to change, here change means to increase or decrease the energy, then it means that energy from some other systems either entered into the system or left the system. So we can say change in energy of the system basically is the sum of all the energies. Here E system is the total energy of the system, including all methods of energy storage, that is the kinetic, internal and potential. And T is the amount of energy transferred across the system boundary by some mechanism. Two of our transfer mechanism have well established symbolic notations. For example, for work, the energy transferred, work is equal to work, W, and for heat, T transferred heat is equal to heat, Q. The balancing checking account statement, if our account is the system and change in the account balance for a given month is the sum of all transfers, deposits, withdrawals, fees, interest, and checks written. It is the energy as a currency of nature. So, suppose a force is applied to a non-isolated system, and the point of application of force moves through a displacement. Similarly, suppose further that the only effect on the system is to change its speed, means when a force is applied, then effective force can change the speed of the system. The only transfer mechanism is the work, so that T is positive in equation reduces just to just W, work, and the only kind of energy in the system that changes in the kinetic energy, so that E system reduces to just delta K. So delta K is equal to W, means change in kinetic energy is equal to the work done, which is the work kinetic energy theorem. The work kinetic energy theorem is special case of more general principle of conservation of energy. In other words, work energy theorem is a special case of law of conservation of energy. Now the second article, the situations involving the kinetic friction, means when a body moves, the motion is opposed by kinetic friction. We take an example, just as seen in the figure. There is a physics book is placed, a force is applied on it, on the rightward, at certain instant, certain position. Then a kinetic friction is a friction force that opposes the motion. If external force is not present, then due to kinetic friction, the velocity of book will reduce. We can compare the red arrows. VA is greater velocity and VF is lesser velocity. It means the body is coming to rest. So here there is a kinetic friction. Consider again the book in the figure as we have seen, sliding towards the right on the surface of heavy table and slowing down due to the friction force. Work is done by the friction force because there is a force and a displacement. The equations for work involve the displacement of point of application of force. The friction force is spread out over the entire contact area of an object sliding on the surface, so the force is not localized at the point. The magnitude of friction force at the various points are constantly changing as spot welds occurs. The surface and the book deform locally, and so on. The points of application of the friction force on the book are jumping all over the face of the book in contact with the surface. This means that the displacement of the point of application of force, friction force, is not the same as the displacement of the book. So the work kinetic energy theorem is valid for a part that can be modeled as a particle. For these kinds of situations, Newton's second law is still valid for the system, even though the work energy theorem is not. In the case of a non-deformable object like our book sliding on the surface, we can handle this in a simple way. So consider a situation in which a constant force is applied to the book. We follow the developing work energy equation, multiplying each side by the Newton's law, x component only by the displacement delta x of the book. So, consider the situation in which constant force is applied to the book along positive x-axis. Since a constant force is acting, so by Newton's second law, the net forces sigma fx is equal to max. So we have multiplied by delta x on the both sides, so we get the product on the left side of the equation is the work done, formula of work done. For particle under constant acceleration, we know that following relationship are valid. Means acceleration is equal to, from the first equation of motion, Vf minus Vi over t. Similarly, dx is equal to the average distance, average velocity multiplied by t. If we use these formulae in the above equation, so that the sigma fx and delta x becomes work, and if we multiply and simplify, then the result becomes 1 by 2 mvf square minus mvi square. This looks like the work kinetic energy theorem, but the left hand side has not been called the work. The quantity delta x is the displacement of the book, not the distance. Displacement of the point of application of friction force. So we can write the above equation as in the form sigma fx multiplied by delta x is equal to minus fk into delta x, means the right hand side formula is as it is same delta k. In other words, we can conclude that minus fk into delta x is equal to delta k. Let us now apply this equation. This equation Let's now apply this equation to a book that has been projected across the surface. Imagine that the book slows down due to the friction. The only force in the horizontal direction. The net force on the book is the kinetic friction force Fk, which is opposite to the displacement delta x. That is delta k is equal to minus Fk into d. Here the negative sign shows that this change in work is opposite to that of work done by the body, which mathematically describes the decrease in kinetic energy is due to the kinetic friction. The next part, kinetic friction in presence of other forces. There are two cases for other forces. First one is that result of friction force is to transform kinetic energy into the internal energy. Increase in internal energy is equal to the decrease in kinetic energy. So mathematically we can write it as delta E internal is equal to Fk into d, that would be equal to minus delta k. The second one is if there are other forces some other forces besides friction acting on the object, the change in kinetic energy is the sum of that due to the other forces, because from the work energy theorem we know. So means delta k is equal to minus Fk t plus E and work done other forces. And now consider the larger system of the book and the surface as the book slows down under the influence of friction force alone. There is no work done across the boundary of this system. So we can write delta E of the system is equal to change in its kinetic energy plus internal energy, that is equal to 0. So putting the values, we get minus Fkd plus delta E internal energy is equal to 0. So finally it can be suggested that delta E in internal energy is equal to Fk. That is, the increase in internal energy of the system is equal to the product of friction force and the displacement of the body. Thanks for all listening and focusing with patience. Bless you all. Allah Hafiz.